Okay, so let's talk about data types and types conversions. Okay, how um, you can work with data on Python programming language. Now, um, in order to do your programming, most of the times you'll be working with data. I think that's logical. Most of the times you'll be working with data. Data in the sense that you will be working with numbers, you'll be working with strings as in alphabets or letters. You'll be working with things that are not numerical. You'll be working with a list of things. You'll be working with things that really are not numerical. Do you understand? So we want to see exactly how Python expects you to put data so that it can be able to work with it. Now there are a lot of data types, but before we go there, I want to show you something very simple. Okay, it's called assignment. How do you assign in Python? For instance, when you're solving a mathematical question and you want to do change of subject, or um, work an equation, what you say is let x equals to 4 or something. Let x equals to something. Where this x is just a variable, right? X is a variable, and this 4 is the value. Do you see? Yes. So x is the variable and 4 is the value. That's basically what assignment means. I'm going to put a comment here and I'm going to call it, sorry, I'm going to put assignment here and I'm going to call it assignment. Okay. Comment called assignment. Alright. So x equals to 4, right? We can say y equals to hello. Alright. You can say z equals 0.2223. Okay, all these are assignments. You're assigning a number to a variable called x, you're assigning y to a hello to a value called, sorry, a variable called y, and this decimal to a variable. So now you can call forth that variable. So anywhere it sees y, it replaces, anywhere it sees y standing alone without quotation marks, it replaces y with this value. Okay, right, let's run it and see. Hello, prints hello. Now if you want to print z, whenever it sees z standing alone, it prints 0.222. I think that makes sense, right? If it sees y x standing alone, it's going to print 4, the value of x. That makes sense. Okay, so that's assignment. Okay, it's important. Now what I want you to understand is this idea. The x means a variable and the 4 means a value. Most people confuse those two. Now you can assign anything to a variable. Okay, you can assign anything. You can assign numbers as you are seeing here. You can assign decimals. You can assign strings. Strings are the things in quotations. Okay, the non-numerical values. Okay, things in quotations are usually strings. Anything you put in quotation means you are trying to tell the computer that this thing is non-numerical. It's actually most of the times it will be alphabets. So don't see it as a number, see it as a string, as letters. Okay, so that's for the assignment part. I'm going to comment it again. So I'm commenting plus the comments. All right, and I want us to do the data types. Okay, data types. Okay, so for the data types, now there are built-in data types. As I was telling you, we have strings, we have numbers. Okay, numeric types, we have numbers. For instance, let's just take them one by one. So okay, I'm just going to go back to my example here. I'm going to uncomment these guys. All right, so this one, this 4 is an integer. Right, let's put a value here and we will call it what will we call it? Have we given integers? We have given. Have we given floats? We've given. All right, we can call it a boolean. Okay, now there are a lot of data types. We're just going to deal with, we'll try as much as possible to deal with all of them. What I need you to understand is a sample of them. If you're able to get some of them very clearly, the rest shouldn't be difficult to understand. Okay, so this is a boolean. Boolean means true or false. Okay, that's what a boolean means. If you hover over it, it tells you that it returns true when the statement. So boolean means true or false. It can either be true or false. Whatever it is, it can be true or false. You don't have to know what it is right now. Just know that boolean are true values, true or false. That's what we mean by booleans. Now x is equals to 4. 4 is an integer. An integer is basically a counting number from 0 upwards. Note, An integer does not contain decimals. Okay, that's the difference between x and z. Z contains decimals, which we call floats. Okay, which we call floats. So x contains decimal aspect, so it contains an integer aspect here. It could have been 2 points, all right, or 4 points. So x contains this, z contains this integer aspect and float aspect. That's the decimal aspect of it. That's why it's called a float. Okay, there are other data types. For instance, okay, this string here, I remember I was telling you anything that is inside the quotations represents a string. Okay, now there are other data types. For instance, you want to save your data in a certain sequence. We can save our data. Let me use abcd now inside something called a list. Okay, a list is created this way. For instance, you're going to the shop and you want to buy a list of things. For instance, you want to buy milk. Use single quotation marks for this. You want to buy milk. You want to buy sugar. You want to buy coffee. Or what do you think? Yeah, I would like to buy. Okay, and you want to buy some yogurt. All right. So this is a list of things you want to buy. Okay, you can have a list of strings. So as you can see, each element in the list is a string. Each element in the list is a string. They are not numbers. All right, they are just strings. Now you can also have another list, list B. Remember, lists are created with square brackets. You can have a list of numbers. Okay, doesn't matter what number it is. You can have a list of numbers. That's integers. You can have a list of integers. You can have a list of what else do you want to have? A list of floats. Okay, you can have, so usually separate the elements of a list by what's the name, comma. Okay, you can have a list of floats. Good. You can have a list of floats. You can have a list of lists. Okay, so this list equals first list, comma, second list, comma, third list. Do you see how it makes sense? You can have a list like this: e equals to a list called e equals to a, comma, b, comma, c. Isn't that interesting? You can have a list of lists. It's the same as this, a list of lists. Remember, a, b, c are already lists, so it's going to represent. You can, if you want, let's print it, and then you will be convinced. All right. So I'm going to print this one. See, it has printed a, b, and c. Makes sense, right? So it's a list. It's basically a container. It can contain anything. We have tuples and we have um dictionaries. Okay, we have sets. I already talked about booleans. All right. um so we have ranges. I think I mentioned some of them will be popping up as we go on. Okay, there's not time to really talk about all the data types we have. Some of them will be popping up as we go on. Okay, and there's one other numeric data type I forgot to mention to you. Okay, it's called, let me call it F. It's called complex numbers. Now I don't know if you work with complex numbers. Usually in engineering computations you'll be working with complex numbers. So yeah, you can have a complex number like this. Okay, I can say 2 plus whatever complex number you have. Note this J represents the complex number part. Okay, so let's print F instead of E this time and see. Oh, sorry, it gives you this complex number. All right, so there are a lot of data types. Okay, we will take them one by one eventually, and we'll be dealing with them and how to go about them. I just for now just want you to understand that they exist and that they are useful. All right, thank you.